Hello guys, welcome back. In this section we are going to know about operators. As I already told you, this section is very interesting and also very easy. So without any delay, let's get started. So what is an operator? An operator is a symbol that operates on a value or a variable. Okay. So basically an operator is a symbol which operates on a value or a variable. If we take 5 plus 2 or a plus b, for example, if you take a plus b, a and b are variables, isn't it? A and b are variables, and plus is the symbol which is operating between a and b. So plus is called an operator. Now I hope you understand an operator is a symbol that operates on a value or a variable. Okay, there are different types of operators such as arithmetic operators, increment decrement operators, assignment operators, relational operators, logical operators, bitwise operators. We are going to see each and everything about these operators in these slides, and also after completing the slides in the next lecture I am going to explain each and everything in hands-on. Okay, so what is an arithmetic operator? It performs different types of mathematical operations such as addition, subtraction, multiplication, division, and modular division. Okay. As you can see on the left hand side there is an operator symbol, and the right hand side it says what is the meaning of that symbol. Okay. Plus is for addition, minus is for subtraction, multiplication has the symbol of star, forward slash is for division, and percentage symbol is for modulo. So what is modulo? When we divide two numbers, the quotient comes under division and the remainder is modulo. Okay, the quotient is division, the remainder is modulo. So arithmetic operators, these are arithmetic operators: addition, subtraction, multiplication, division, and modulo. Okay, so next comes increment or decrement operators. These are used to increment or decrement the value by 1. Okay, so for example, if we take a value of 6, if we increase the value of 6 by 1, it becomes 7. This is nothing but increment operation. In the same way, if we decrease the value of 6 by 1, it becomes 5. It is called decrement operation. So in C, plus plus is used for increment operation and minus minus is used for decrement operation. As you can see in these slides, I had kept what is pre-increment, post-increment, pre-decrement, post-decrement. It is difficult to understand in PPTs. So what I will do is I'll explain you while we'll do our hands-on. Okay, in the next lecture we'll start with our hands-on. So whenever there comes increment and decrement operators, I'll explain pinpoint about pre-increment, post-increment, and pre-increment, post-decrement operations. Okay, so next comes assignment operators. Okay, what is an assignment operator? This is used to assign a value to a variable. In general, equal to symbol is called assignment operator. Okay, so what is an assignment operator? It equals is an assignment operator. For example, if you multiply 5 and 2, the result will be 10. 5 into 2 equals 10. Okay, so we are assigning 5 and multiplication of 5 and 2 to 10, isn't it? So how we are assigning? Through a symbol called equals, is equal to. Okay, so this is equal to symbol is nothing but assignment operator. You can see here the following are the assignment operators: equals, plus equals, minus equals, star equals, forward slash equals, percentage equals. Okay, addition equals, minus, subtraction equals, multiplication equals, division equals, modulo equals. We'll explain each and every symbol in detail while we do our hands-on. And next comes relational operators. Okay, these operators check the relation between two operands. The return values are 1 and 0. If the result is true, it returns 1, else it returns 0. Okay, if false, it returns 0. So what is basically a relational operator? What is the relation between 5 and 2? Yeah, 5 is greater than 2. This greater than is showing the relation between 5 and 2. So that's why greater than is a relational operator. In the same way, 2 less than 3, 3 equals 3, 4 not equals 3. These all are showing the relations between these two numbers. So these are called relational operators. As you can see, the return values are 1 and 0. So what are these return values? Let us check in our hands-on section. No need to worry now in these PPTs because we have a lot more to discuss in this section. It may take some time, but we'll explain all of these in the upcoming lectures. So the following are the relational operators such as equals equals. We had written two equal symbols here. You can see two equal symbols here. So in C, if we say the relationship between two equal numbers, in general we'll get 3 equals 3, but in C we'll say 3 equals 3. Okay, and also the greater than symbol, less than symbol, not equal symbol, greater than equals and less than equals are all relational operations. Okay, operators. The next comes and, or, and not truth tables. So what is this and or not? These are basically called gates. Okay, so you will see gates in digital electronics. Not only in digital electronics, in NCERT textbook of 12th class physics last chapter, you can see these gates. Okay, so what are these gates and why are we going to discuss this? You will get to know why we discussed this in later on PPT slides. So what is basically an AND gate, NOT gate and OR gate? Okay, AND gate does the multiplication operation basically. So see here, we are taking two inputs A, B are input and we take an output. Okay, so inputs are total, there are two inputs, so 2 power 2 is 4. We have total 4 different combinations. So in mathematics you have learned permutations and combinations and probability, right? If we have two inputs, we have total 2 power 2 outputs, so that is total 4. So 0 0 0 1 1 0 and 1 1 are the total possibilities. So if we multiply 0 and 0, the output will be 0. If we multiply 0 and 1, the output will be 0. If we multiply 1 and 0, the output will be 0. And if we multiply 1 and 1, then the output will be 1. This is basically a multiplication operation. So AND gate basically do an multiplication operation. Okay. And in the same way, OR gate does a an addition operation. Okay, you can see it's the same input combination 0 0 0 1 1 0 and 1 1, 0 plus 0 0, 0 plus 1 1, 1 plus 0 1, 1 plus 1 1. Okay, this is the truth table for OR gate. So what is this 1 plus 1 2, right? Why are we taking 1? These are basically the combinations of only zeros and ones. We do not have 2 in the combination of 0 and 1, so we represent 2 as the value of 1. So OR gate basically does the addition operation. And what is a NOT gate? The name itself suggests that it is quite the opposite. Like the output is the opposite to the input. If the input is 0, the output will be 1. If the input is 1, the output will be 0. This is basically called an inverter. Okay, so how can we define this AND gate? So if both the inputs are 1, the output will be 1. If any of the input is 0, the output will be 0. So what does this, if we take 0 as false and 1 as true, we'll say like if both the inputs are true, then the output will be true for AND gate. In the same way for OR gate, if any of the input is true, the output will be true. Okay, see here, if one input is true, then the output becomes true. Unless the input has both false, the output will be false, else the output will be true in any of the different cases. You already know this NOT gate, right? If the input is 0, output is 1. If the input is 1, the output will be 0. Like you can say like the output will be true if the input will be false, else the output will be false if input will be true. So these are the relationships between AND, OR and NOT gate. You basically remember these things. the table. No need to remember these symbols. Basically, these symbols are useful in digital electronics rather than we are using in this C programming. These have different symbols in C programming. Let us discuss it in further slides. So in the next slide, you will find logical operators. So what are logical operators? Logical operators return either 0 or 1 depending on the logic. You can see ampersand, ampersand. You can see this symbol ampersand and ampersand. This is basically the AND. As we discussed, the logic for AND returns true if all the inputs are true. This is the symbol for OR. Logical OR returns true if either one of the input is true. And this is the symbol for NOT. What it says, returns true if the input is false. These are the logics for AND, OR and NOT gates. Okay, these are nothing but logical operators. We can perform these logical operations in C programming using these symbols. The next comes bitwise operators. So these are same as that of the logical operators, but the difference is we'll do this on bitwise. Okay, in order to make the process fast in the operations such as addition, subtraction, multiplication, division, etc., the operations are converted to bit level. Okay, so basically you can see bitwise AND or XOR, bitwise complements, left shift and right shift operators here. The left is the symbol, the right is the meaning. Just remember these things while we'll do our hands-on in Dev C++. We'll discuss all these things, no issues. We'll discuss every pin to pin, point to point. Okay. Yeah, this is the last slide, and we have not only these operators, we have many different types of operators. The important among them are comma operators and size of operators. So comma operators are nothing but if we want to define different types of variables like a, b, c using int a, int b and int c. Instead of defining it in different lines, int a, and in the next line we'll define it int b, in the next line we will define it in int c as int c. Instead of doing such things in different lines, we can use this comma operator. We can get it like using int only once, int a comma b comma c, so that int belongs to a, also belongs to b and also belongs to c. So this is the use of comma operator. And size of operators are nothing but it returns a value so that the size it defines the size of a constant. It returns the size of a constant. Okay, the value it returns will be the size of constants, variables, arrays, anything. It returns the size. Okay, so basically we'll see these operations later on in our hands-on videos. So for now, let's meet us in the next lecture and let's see how we get it implemented practically, these operators. And I hope you enjoyed this video. Thanks for watching.